Rylan said he did something else, right? What do you think Rylan did to solve the problem? Talk to me.
I think that he did. He added one that 399, like what Eric did, but he also
And why would he add one to the 398?
To get the, I mean not to 398, the 399. Add one to 399 to get 400.
Okay.
And then add two to 398 to get 400.
Oh, I see what you're saying. You're coming on another strategy here, I think. You're saying he turned them both into 400.
And since 2 plus 1 equals 3, after you add 400 plus 400, which gets you 800. 800 minus 3 gets you 797.
Do you see that taking off of those? Yeah. Wow. And a whole other strategy came out of here. I think we were here, Rylan. Where are you, Rylan? When you were thinking about this, you changed these to both 399s. Why did you do that? From the last problem. And you knew 399 plus 399 was what? 798. And then how did you get your answer from there?
I just took one away. Minus one from, subtracted one from 798.
Nice. And why did he subtract one, everybody? Because he added one here, right? He changed the problem. So if he added one, he had to take it off. Just like, tell me your name, honey. You told me, Nathan? Nathan added 3, so he had to take 3 off. So I want you to look at these strategies before we go back to our seats. We've already gone over a little bit, but you guys were doing some great thinking, okay? Look at what all of these different strategies. I want you to talk to your partner one more time. Which strategy do you think would be the one that you would want to use to be really efficient with your math? If I said you had to finish this problem before you can go to recess, which one would you pick to get that answer in a very timely manner? So what do you think? What strategy do you like?
We already knew that.
Do you like a strategy like Chloe was explaining to us, or a strategy like Nathan or Rylan were explaining to us?
I like Nathan. I like Nathan.
You can always like your own, right? Okay, so here's what we're going to do, guys. I want you to go ahead and we're going to walk back to our seat. But as we walk back to our seat, we're going to count. Yeah, just like kindergartners. But we're going to count by fractions. Are you ready? We're going to start with a third. And as you walk back to your seat, we're going to count by 1/3. Are you ready? Go ahead and stand up. 1/3. 2/3. 3/3. 4/3. 5/3. What comes next?
7/3.
7/3. 9/3. 10/3. Okay, I'm just technology. Well, Miss Loves is going to be smooth on her transition, but not so much. Okay, you want me to erase it up? That'd be great. Could you erase it? Did I turn it off? Whoops, Miss Loves turned it off. So when you're counting by fractions, you can count by fractional pieces even when they get the numerator greater than the denominator?
Yep.
Interesting. I like that. Okay. I hear it. It's juicing up, getting ready for us. Guys, that's one of the best number talks I have been able to be a part of. You guys are rocking it. I love your discussion. I can't wait to hear what you talk about during our lesson today. We're going to wait on the projector to warm up. It's warming. Maybe. I love technology. It works. It's great. And I wonder, is the mute still on? Or do you think because I turned it off and turned it back on, well, it should be fine? It's going.
You're too
You see it's going? Okay. I have very little patience usually to push your button. Ta-da! There it is. Look at that. Awesome. So, there you are. Smarter Primary, 5th grade. Woo! All right. So, let's see now if I can get this to work. Oh, whoops. I'm not sure what that was. Did you hear that sound? Okay. So, I'm going to do a really quick, like 2-minute number sense routine before we get into our lesson for the day. You guys ever done one of these subitizing multiplication cards? You ever done one? So, what I'm going to do is I'm going to show you a picture of some dots. And I want you to tell or think, how many dots did I see? Don't say it out loud, okay? Just think it in your head and I'm going to let you talk to your table. Are you ready? So, let me go back. Look at that. Think about how many dots you just saw. Now talk to your neighbor about what you saw and how you know how many were there. Did she count all those dots? You don't think so? So she said she saw 6 circles with 6 in each one, and then she said it's 6 times 6. How does she know that's 6 times 6? How does she know that, Eric?
So I think she counted the boxes. So there were 6 boxes. There were 6 dots in the boxes. So then I think she did 6 and 6, 36.
Interesting. So what is why did she say multiplication? What does multiplication mean? Talk to your group. What does multiplication mean? Why did she say it was 6 times 6? Yeah. Okay, come back with me. Tell me your name, honey. Zachary had a thought. Zachary, why do you think she said 6 times 6?
Because there's 6 groups of 6.
Groups of, right? This sign right here means groups of. So she saw 6 groups of 6. Do y'all agree with that? Let's look and see. Whoops. Now look at the next one. 6 groups of 6. Do you agree with that? Anyone see anything different than 6 groups of 6? No? Alright, so you see that. I'm going to show you one more. It's going to change slightly. Look at how it changes. See if you can tell me how many dots you see next. Are you ready? Here's the new one. It's only going to be up for a minute. Sorry, this is the wrong one. What'd you see? Talk to your group. What'd you see? What changed? You saw 7 times 6. Where? He said. Tell him where you saw it. You saw what? Whole set of the dots. He said he didn't see 7 groups. Can you explain to him? Did you see that? Did you see 7 groups with 7 dots? No, you didn't? Well, we'll look in a minute. Okay, so tell me, what did you see on the last one that I showed you? What did you see, honey?
I saw 7 dots in each circle, and there were 6 circles. So
Okay.
6 times 7 is 42.
So she said she saw 6. Does everybody agree with that? Do we have anybody had a question? Like I heard some questions out there about they didn't necessarily see some things that other people saw. Did everybody see that? That you saw 6 groups of 7 things? Would you agree? Was it 7 groups of 6 things? No, it wasn't 7 groups. Let's look and see. Nope, there were 6 groups of 7 things. So what changed? What changed? They just added one more to each what?
Group.
Each group. So the group size changed, didn't it? We changed our group size from 6 to a group size of 7. And so what did that do to our product? It went from 36 to what?
42.
So it went up by how much? What do you think? What did it go up by? 6. Did y'all see that? It goes up by 6 because we added one more to each group, and there were 6 groups. Interesting. I love this multiplication subitizing that you guys just did, seeing your visuals there with your multiplication. So you may get to do some more of those later on. So now, here's what I need. Tops on your markers. And if you have your whiteboards out, you can have those out because you will be asked to write an equation with some of the work you're about to do. But we're going to start with our lesson for today. So today you're going to be exploring. I hear you kind of talked about some of your pattern blocks on Friday and some of those fractional pieces, so we'll explore those for just a minute. But today what you're learning and exploring is equivalent fractions. Okay? Turn and talk to the people at your table about what does it mean to be equivalent. What does that mean?
Be equal.
Okay, so come back with me. What does it mean to be equivalent? Talk to me. Equal to? Somebody say more. The same. Can you give me an example of something that's equal? Give me an example of something that's equal over there.
1 and 1 cookie.
1 cookie and 1 cookie, that's equal, right? 1 and 1. Yeah, exactly.
There's 1 whole. Or you can use 2 halves.
Oh, 1 whole or 2 halves. That would equal that 1 whole. Interesting. So they mean the same, or equal means the same. So you're going to be exploring some of those equivalent fractions today, but here's what you're going to be learning and telling me how you know they're equivalent. So I need to know how you know they're equivalent, and the way you're going to be able to know you've learned it today is you're going to be able to tell me why they are equivalent, how you know it, and you're going to have to show an equation, okay? So turn and tell your partner, what are you going to have to do to show you know it? Write an equation and what else? You got to show it with a what? A model, right. So how are you going to know you know it? Show it with a? That's right, a model and a what? And a model and an equation. So as you're working with your partner that you're working with, say, did we model it? Check. Did we make an equation? Check. Right? So you want to be sure you do both of those today. So let's look at our first Explore. So you have your pattern blocks out there, and I know you kind of already did this. I just want to be sure we all are clear on which piece represents what part of the whole. Okay? So go ahead with your partner, and if there's groups of 5 like this, there could be a group of 3 and a group of 2. So you'll have to decide that if you have a group of 5. And I want you to figure out which piece represents which of those fractions. 1/2, 1/4, 1/3, 1/6, and 1/12. So you and your partner, I need you to be able to explain to me which one of those represents each fraction. Do you know who you're working with? Y'all gonna do a group of 3 here? A group of 3 here? Awesome. You have about 3 minutes before we talk about which of those pieces represent each fraction. So what did you say those were? Okay, great. And so when you write that, Chloe, as a fraction, write that as a fraction. What does this is 1? One part, and does 2 make what? 2 parts. So if you want to put them like this, what are y'all coming up with? How do you know that? So when you write the fraction 1/4, what does the 1 tell you? What does the 1 tell you? It's the 1 whole. So show me one of the pattern blocks. The red one is. So how many? What does the numerator tell you? I like that. So this is 1. Can you show me what 2 halves are? So write 2 halves, please. So that's 1 half and that's 1 half. Can you write 2 halves? 2 halves. How do you write that? What did you just make? A whole. So he has how many halves? 2 halves. Yeah. So can you write 2 halves? How would you write 2 halves? How would you do that? What does the numerator tell you?
Can I see a whole, please? Can I please have these?
You guys don't have Apple TV, right? Can you get the L? Thank you. Oh, I like what you're doing here. Tell me about this. What is happening?
I can't find them.
Oh, you know what?